Okay, we mentioned in the previous stormwater section that soils are very important. And soils are important for stormwaters, and they're also important when we're talking about foundations, which is going to be the next unit we're going to do. So this works out a good time to talk about soil. Now we often think of dirt is dirt is dirt, but it's really not when we're talking about civil engineering and building structures. Why test the soil? These are the same kind of things we would think happen. The buildings, they're sitting on the dirt. The properties can change a lot, and we need reliable soil information when we're building. These are the kind of things that we need to know. You'll notice drainage is something we talked about, wastewater disposal, bearing capacity, settlement of foundations. These are all things we're talking about right about now. So what's in soils? Water, that's our infiltration. Air, it's not solid. It's a bunch of little tiny particles, and there is air between there. Minerals is what we would think of as the dirt. And then organic material. That's plant matter and other matter that is worked down in between the dirt particles. There's 4 kinds of minerals that are in our dirt: gravel, sand, silt, and clay. We're going to look at those. And you can get this information here. In fact, we're going to be using this web page in our activity today. When you go to this page for your activity, you're going to be picking an area of interest. And we're going to be actually looking at the area around the stony point. And we have descriptions that we're going to be finding off of that webpage and that are used in engineering to describe the soils. You'll have to look at these and use your packet that I'm going to give you to see what these are what each letter stands for. This is the Unified Soil Classification System, which we always write as USCS. First, we define it as how thick the particles themselves are. We also look at the color of the soil. You should pause and take notes on these slides. If it's very thick grained, think beach sand, we would talk about it by the grain size. If we're talking about very fine grained soils, then the plasticity comes into effect. First, to find the size of the particles, we would go through a series of sieves that divide it out into different sizes. This is like wire mesh. They look like this. So all but the biggest particles would stay here, everything else would fall to here. Then this holds the biggest particles that are left, and the smaller ones fall to here, and so on down. And we get our amounts divided onto these different sections: boulders, cobbles, gravel, then sand, and finally down here silt and clay that are very, very fine particles. Well graded means that all the particles are present. So we'd find all the sizes of particles. Poorly graded soils mean that the particles are all roughly the same size. In other words, there's large air gaps in between. Clean soil means there's no fine particles. Again, think like beach sand. It's all pretty big grains. Dirty soils is where it's got a lot of fine particles. Plasticity refers to the consistency of the fine-grained soil. Does it stick together? Can you roll it into a little ball and it'll stick together? We have our different soil types. You should write down each one of these abbreviations. Gradation says well graded or poorly graded. Are all the different sizes of it in this part of dirt we're looking at, or is it all one size? And then plasticity, high or low. Read over this slide. I'm not going to read you these slides. Just go ahead and read these. when you're determining what kind of dirt you have, you would do a number of tests on it. Crushing it by hand, how easy is it to crush? Dilatancy, toughness, and then you would find the soil types. Plasticity has to do with several different things. The plastic limit, the liquid limit, and then the plastic index. We can find the plastic index by taking the liquid limit minus the plastic limit. You're going to do some calculations with this where I'm going to give you some of these values and we're going to find the other one. Now this table is often used, so I'm going to give you a copy of this. And basically what it does is you follow the flow chart down to find what kind of soil you have at the bottom. If we go this direction on that table, we see the coarse-grained options over here, which are gravel and sand. This says there's more gravel than sand, and this says there's more sand than gravel. To take you to these two other sections that go down. Then you answer each question and determine which one you're going to, and so far down to the bottom. If we go to the light side over here, where sand is more than gravel, we see the sand one. And we also have a plasticity chart. Notice this is the liquid limit we mentioned before and the plasticity index. It's just like any other graph where you go over to the liquid limit and then up to the plasticity index you'd use to tell which of these four sections or these two sections here you're in. For instance, if I had something with a liquid limit of about 77 and a plasticity index about 57, I'd come over here and I'd be in CH. This says above the line. We were on that last one, we were above the line and in the shaded area on the plasticity chart, making it a CS. For foundations, we're going to see this again when we talk about foundations, but this is the order of kind of darts we'd like to make our foundations on. We'll see if we have poor ground for foundations, we have to use a different kind of foundation. And we're going to see the same chart in our next section as well. This is how much allowable pressure we can have on different kinds of soil types. That's